And again, my name is Larry Mead, and just sort of as a brief intro, I am with Azure Engineering. I'm a principal program manager, but prior to that, I actually worked on mainframes for about 17 plus years, and also some enterprise Unix. And that was before I started with Microsoft, which was a little over 25 years ago. And when I was working on mainframes, I was actually working either in commercial banks or I was working for software companies that provided systems for commercial banks. So I do have some experience in the financial services arena. And since being in Microsoft, I immediately got thrown into doing that kind of thing with loans with a large auto manufacturer, and then, brought in insurance company and brokerage firms over the years, and really concentrating on mission critical and high volume systems and how to best host them with Microsoft technology. So I do have a background both in the mainframe world and also in the world of Microsoft. So with that, the first thing that what do we talk about when we're talking about mainframes? What we mean at Microsoft when we say mainframe is either the IBM Z series or the Unisys ClearPath series. That would be, and with the Z series, that could be a number of different OSs. There's ZOS is by far the most common. But there's also ZTPF, which there are some financial services companies that do that for high volume processing. For instance, there's some credit card companies that use ZTPF and also some other payment systems. There's ZVM, which is essentially virtual machines that run in Z. There's ZVSE, which is more of a really smaller systems, and then there's Z Linux, which is essentially running Linux on a mainframe. And then in the Unisys world, there's the legacy Burroughs, which is the MCP or Master Control Program, and OS 2200, which is the legacy Sperry. So we cover all those platforms with how to best host them in our cloud platform, Azure. But we also look at some other things, which some people also refer to what we call mid-range as mainframes. That would be the IBM I series, which is like the OS 400, and also the P series, which is like AIX. And then there's also the various flavors of Unix like Sun, and then HP UX. And so we do work with all of those and how to best host them in. And the interesting thing is that we do have paths, to Azure for all these types of systems. And there's not just one way to do it. We could look at keeping things more or less the way they are, which is the rehost. There is taking the architecture, keeping it more or less intact, but then taking and changing to a different language, for instance, getting rid of COBOL and maybe changing over to Java. That would be refactor. And then re-architect. That's pretty much starting from scratch and then saying, let's go back and revisit the business problem we're trying to solve and see how to best do that in a cloud environment as opposed to where it came from on a mainframe. And I've got sizes ranging from 100 MIPS to over 100,000 MIPS. MIPS stands for millions of instructions per second. It's just a sort of an arbitrary number that IBM's had over the years for measuring compute power for mainframes. There's also something called MSUs, and one MSU is about 8.1 MIPS. Regardless, it's a way of being able to sort of look at sizes. 100 MIPS is a small mainframe. 100,000 is a very large mainframe. So with that, let's look at why people are doing this. You've had a mainframe for maybe 30, 40 years. Why would you want to, go and, move it to something else? And, we get people who actually seek us out for help in this area. Perhaps they need more flexibility and choice with what they're trying to provide. They're trying to meet new markets. I know that that's something that happens with a lot of companies that I work with, especially like in the brokerage, insurance, and commercial banking world. The newcomers on the scene don't have these legacy environments, therefore they can come in and have a wider range of options potentially that they can deploy with. And so if you move into a cloud environment, then you too will have that capability. Um, and the other one is, well, I need to respond to my business more quickly. I know that I've worked with brokerage firms who everyone's got their brokerage information. They can look on it on their phone. I know I certainly do. So what does that do? Well, that means I have to provide those types of services to the mainframe. And that does two things. One, I have to be able to maybe have a front end to that mainframe. And I also am driving up my MIPS because now I have more people are using the system, and it's not really providing me any extra income. I'm just, my costs are going up. So there's some things that take place that are that you want to be more agile, but you also want to do it, which is the third thing, in a more cost-effective manner. Now, this is probably the reason people seek us out in the first place, because typically the hardware is costs alone, and the software costs alone are much more expensive than what you would run in a cloud platform like Azure. But that they find that there's other reasons too. And then the final one is a lot of people are having a hard time getting the legacy skills. Certainly we've seen that with the number of customers, for instance, having difficulty finding COBOL programmers, or perhaps if you've got things like assembler, another language on the mainframe, that's even harder to find people who can still do that sort of thing. And without the skills, my agility goes way down. So these things are all sort of, intermixed, but probably one of them is the driving factor to why you might want to do a migration to a cloud platform like Azure. So, Microsoft, we developed a sort of a transformation program for the mainframe, and we had for years been working on moving it mainframes into Windows environment for about the past 12 years. But we also said, okay, if you're going into Azure, then you could do this with Linux also. It's not unique to Windows. But the way to do that, since we had the experience of this 12 years that we spent with partners, is you do need the tools and technology. You need to have the systems integrators and the service providers to provide the capability of getting this done. Then you also need the technology from a hosting environment, which is what Azure is providing there. So that's where we get the ecosystem that makes it such that we can, effectively do this type of program with customers. So, this slide, this is the classic Gartner 5 R's, but we added one to here, which is the first one, remote hosting. This is where the customer might actually still keep a mainframe operating system like ZOS, but run it in a hoster, before moving it into the cloud environment. And you ask, well, why would you do that? There is some effort in moving to getting off a mainframe, and it can take 6 months or more, maybe up to 2 years, depending on the applications. And a remote hosting might give you the ability to get out of your data center and then move to the cloud environment as time allows. The reason you might have to do that is perhaps you've outgrown your data center, perhaps you're facing an upgrade. There's various different reasons for doing that, but that's one of the things that we've sort of added to the the 5 R's. But the others, as far as retire, quite frankly, there's a lot of applications that, especially in the reporting area, that could probably be discarded or retired. And maybe code even within applications is not used anymore. That could be retired. Retain, some customers for various reasons might need to keep their systems on mainframes. A lot of times government regulations or data sovereignty would keep them from using a cloud environment. Well, in those cases, we have the ability to sort of replicate data to be able to handle those types of things. And that's an area that we also have some capabilities. We also have the and we have customers, especially for BI. This is something that would be doing. Like in the last piece, I saw like connections to DB2 being where you might pull data into this, analysis that you're using. That would be a good example of wrapping systems. The replace is where you might have a packaged application. We actually find that in the insurance industry moving forward, and we also find that in commercial banking, where Duck Creek was mentioned in the last presentation. That's a insurance application that we've seen customers move to and replace their existing COBOL applications on, for example. That might be something that you're doing. But the most common that we see is this idea of re-platform, rehost, or refactor. The term re-platform is essentially meaning that you're keeping the load modules on a mainframe, but you're converting them into something that can run in x86 on Linux. So that's something that we have the capability to do. This does not require source code to do. So if a customer no longer has source code that matches their programs, and there are people like that, companies like that, then this is a potential option for moving to the cloud. So that's something that is an option. If you have the source code, though, you're probably better off recompiling it for the target platform. And then the question is do I want to do it? As mentioned before, do I want to keep the code as is? That's the rehost in the terminology we have here. And then the refactor would be I'm going to change it to something like Java or C#. So those are that's the most common things that we see, and of those, probably 50 to 60% are the rehost, but there's more and more refactor that's going on. Then that last one, the re-envision or re-architect, that's where I'm designing from scratch. Now, why are you doing that? Well, quite frankly, some of the systems might be so old they're hard to maintain, and we've run into that with several commercial banks where they actually they don't, they want to get off the code more than they want to get off the mainframe. So moving into a cloud environment is perhaps a way that they're able to do that. So these are all, things that we can sort of look at, and the key thing is what are the business initiatives that are driving that, and then we'll match the approach based on what those initiatives are. So this is just giving you an idea that we're not really new to thinking about what mainframes are and how we would do those in Azure. So if we're just looking down at various things that mainframes have in them. They've had some capabilities since the 70s and 80s that are pretty good, the ability to withstand processor failures and alternative recoveries. And we actually worked on those. A colleague of mine actually helped get that developed with the platforms with Intel and Itanium and Nehalem in the 2000s. Now, that technology has since moved into all x86 type compatible systems, or it's available to, not all of them have it. And then that's what we use to host in Azure. But there's other things like mainframes have something that's called like a coupling facility, which is how two boxes can sort of be scaled out. And they can use something called a parallel sysplex, which is sort of like a scale out capability for something like DB2 or CICS to be able to run. This provides both availability and also provides extra compute power. Well, we have ways of doing that in Azure too. We can have geo-redundant capabilities, and we can use things like Redis Cache and other capabilities like that to do the data sharing that the coupling facility does. And then we've got various other things. For instance, I've already mentioned that IBM has something called ZVM and Prism. Those are things that allow these things called LPARs, or logical partitions, to be able to run on the mainframe. Well, guess what? Those are essentially like VMs. We can run things like within Azure virtualization. We have VMs that can run. Mainframes have a lot of capability around security. They have RACF, Top Secret, and ACF2 are three of the common ones. Well, we also can host Active Directory or Azure Active Directory within our environment. So, there's capacity on demand in the mainframe, but there's also, elastic computing and scalability capabilities that we have. I've already mentioned the prior session had a lot about using all the analytics services available. The last one I want to sort of talk about is, even if you're not moving everything on your mainframe today into Azure, you might want to seriously consider moving over your development environment. This can be done either with a partner that has a development capability for something like COBOL or assembler that can run an x86, and actually even IBM has something which is Z development and test. Those can run an x86, and you can actually host those in Azure. So even if you're not moving the core system themselves, you could potentially move them over. And also, if you are doing re-architecture or refactoring, that opens up the door for all the capabilities that you have for doing other types of environments that you can do. For instance, I might want to use something like a Kubernetes capability, or I might want to use a serverless compute and then host those, those systems. So with that, I'm going to look more specifically, and what does that mean for financial services? Well, this is financial services, as Ron mentioned, takes up a large percentage of the existing mainframes. By our calculations, it's about 40% of all existing mainframes are in financial services, and we see a lot of customers in both in core account processing. That would be both with third-party applications from ISVs that you can now host in Azure, but it's also with systems that have been developed in-house, how to move those across. So with the online, we can talk about rehosting it, as I mentioned, or you could perhaps re-architect that into something like running it in a Kubernetes cluster. We do see that a fair amount, and we see that quite often in things like payments, et cetera, which we have there, where you have high volumes of transactions, getting it a lot of compute that you can have thrown added as part of being able to scale. That's something the cloud's going to offer you, the ability to have a large compute clusters that you can then work with. But I also briefly want to touch on the batch. There's a lot of batch in financial services, and the end of day processing, traditional batch environments, that's all just scheduled and run. But a new approach that a lot of customers are taking is being more event-based. They're saying we don't want to be tied specifically to when I run something. I want to run something based on an event that happens. It might still be a batch type run that's doing, but I can do that based on when something changes. For instance, the market closes, I get in the new values for what a stock is worth or something of that nature. And that leads us into the brokerage type of processing. This is where you're getting into having peak period processing. This is where the cloud, I can scale to that without having to run and pay for it all the time. So I can have peak periods, for instance, my start of day or end of day processing, or a lot of times with brokerage, things like end of month or end of year, those types of things cause events to have a lot of things to be calculated, like fees and dividends and that sort of thing. So this can all be done in a cloud environment where it's sort of rethinking how we do things as opposed to having it just scheduled through a job. As mentioned with insurance, we see both personal insurance, but we also see business insurance. And the three things that sort of leave you with this is for most all these environments, the cloud offers capabilities for backup and disaster recovery that are not as easy to have within a mainframe, or they're very expensive to have within mainframe, whereas you can have just paired regions available within cloud environment like Azure can just take and do that. As I've already mentioned, dev and test, that's something that at the very minimum, I think most customers are interested in. Can I take advantage of the cloud for that? And finally, from a perspective of data sovereignty, this is where we need to look at how easily can I have environments available within my region. And one of the things Azure provides is we provide data centers all over the world that help that happen. And if you can't have a data center available in your region, then we offer solutions that actually can run on premises with our Azure Stack capability. There's something called Azure Stack Hub, which would allow that to take place. So we see all these with financial services systems. So this provides an example of being able to what are the actual services that you could run in Azure to do this. And I've actually got this being done in really two different ways. This is if I refactored code to run in a Kubernetes cluster into Java from running originally with COBOL system. And this is where I'm keeping COBOL more or less intact, and I'm using a third-party processor that emulates either CICS or IMS TM to then be able to do this. Then once you're in Azure, I then have the capability to use things like Redis cache, or I've got RDMA there also. That's the capability of doing high speed memory type processing, sort of like HPC systems. But we also have the capability of running different types of databases out here, either from something like SQL Server, but also open source, for instance, like Postgres. I also briefly want to touch on Cosmos DB or any new NoSQL solution. We see those as good alternatives for vSAM, which is a is a virtual sequential access method on a mainframe, which we see a lot of mainframe financial services systems have. But other things to be interested in, remember I talked about streaming services. Azure has a stream analytics, and Kafka has our event hubs for being able to do that event management, but also with things that we might do with analytics, we do have things like running Spark with something like Databricks, and also be able to do the Power BI. So very briefly, if you are re-architecting, let's say you're doing something that's going to affect all accounts within a system, like I'm calculating fees, and whether it's core banking or insurance or for brokerage. Perhaps I would want to do that with a Spark job where I could apply a fee calculation to all accounts. That gives me the ability to put a lot of compute power against it and probably run a lot more quickly than the sequential process that the mainframe does right now. So we actually have some customers who are extracting to something like a Spark cluster in Azure to be able to do that, and then are actually reapplying it to their more something like a vSAM or a DB2 environment. So these are all options that allow you to take advantage of the power that the cloud is bringing to you, and do it in a reliable manner, because in each one of these pieces, I could be doing it with regionally available storage, and I could fail over between multiple regions. And I can also have high availability within the region that I'm running itself. So this is how you're able to get a lot of that high availability you need, but also that ability to have disaster recovery. And then, since we do allow data centers in multiple regions, we typically can meet the data sovereignty requirements. So this is just an area where we're talking about the various different type of capabilities that are available in a mainframe, and how we might be able to run those in Azure. All of these, from mainframe compute all the way through transaction facilities, are all things that are available within Azure. and then all those various languages could run also. So this is just giving a, showing how the various things might look like on Azure. If you started off on the mainframe, if you're taking more of a rehost view where you have, the logical partitions that are running copies of the OS that then in turn run the transaction monitors and the code. Well, you could do all that in running in Azure too, and you could then deploy that either into virtual machines if that's what you'd like to do, or you could deploy that in containers, and you can even host that into something like a Kubernetes cluster. Our partners who provide COBOL and the emulation of things like CICS and IMS can all typically be deployed in container systems. And then that can all be load balanced through something like the Azure Load Balancer up front using the Active Directory and things of that nature. So one of the last things I want to touch on is a lot of customers ask, well, how do I map, compute power in the mainframe to what's on, cores on Azure? And there was actually a study that was done about 10 years ago where we looked at MIPS and then how the MIPS mapped. And so this is actually we are actually doing a little bit better than we used to, but we ran something like a TPC-E benchmark in COBOL, and then we looked at how MIPS matched to a core. We found that we got about 288 MIPS per core for a CICS and about 170 MIPS per core for running a batch process. Now, to be conservative, we typically say 150 MIPS is probably what you're looking at. Now, that's for COBOL. If you're running assembler, I would say it's more like 100 MIPS per core because assembler is just that much more efficient of a language. So with that, get to my summary because I think I'm about out of time. This is sort of the why do this with Azure? Well, we do have a lot of experience with doing this. As mentioned, I've been with Microsoft 25 years, and I did 17 years with working with mainframes prior to that. I go back to the 70s with mainframes. But there's other people in the company who also have that level of experience, and we've been doing this for years. And we have resources in our field, but also in our engineering group, who I belong to, both for applications and data, but we also have what's called global black belts, which are people who work with our field to do this. And what this allows us to do is then take the various Azure technologies and then use them for things like we have a well-architected framework for deploying this. We have architectures that are out on Azure that can show how to best effectively move workloads into Azure. I have a number of them I've written myself, but also a number of colleagues that we have for being able to do that. And then finally, we do have a concept of sort of a modernization journey. This is, since we've done this before, we kind of know the sort of steps you might want to take and then how to, take this and do it in a way that where you are minimizing the risk, because anytime you do a migration, there is some risk. So what you want to do is have a process in place. And what we can do is we can take this process and then apply it to how you best would be able to migrate something like this into an Azure environment. And with that, I have gotten to the end of my presentation.